Welcome, folks. Just getting things set up and getting the link up into the Google Classroom. And we'll start the lesson in a couple of minutes. All right. It's good. We've got 5 people into the chat now. And we'll give it a minute or two to just finish up, and then we should be able to start. All right, getting more people coming in. We're up to 8 now. All right, folks, it's 1 p.m., so we'll get started. Welcome to the 13th day of remote learning. Today's joke is, what did the buffalo say when his son left? Bye, son. For more terrible jokes, don't forget to reduce the like and subscribe button to lowest terms. Thank you for your support, and happy Wednesday. Today, we're going to take a look again at our techniques for solving equations, and we're going to find yet another way to use them. So in the last little while, we've solved a whole variety of different types of equations, and we've also used the solving skills from equations to change the form of a linear relation. We've had slope-intercept form and standard form, and we've talked about changing from one to the other. Today, we're going to be using our solving skills to take a formula and rearrange it from being a formula for one thing to being a formula for something else. So that's our goal, rearranging formulas. Just a quick reminder, if you're the second or third last person on the stream at the very end, I'll be taking questions at that time, and if the stream drops down to just one student, I have to shut it down. So if you're one of the last few, if you don't mind just leaving it open until everyone's had their questions answered, that would be fantastic and very much appreciated. Okay, so let's take a look at the paper here. Do a little rotate, get everything into focus. Rearranging formulas. There we go. Good to see people saying hello in the chat. And this looks left to right reversed, like mirror imaged on my screen, but I understand that it should be fine on yours. So we are going to move ahead with what's here. So our topic for today, rearranging formulas. It's May 6, 2020, and we're going to start by jumping straight into an example. And we're going to start with a really easy example, one that you could do in your head, and then we'll build from there to much more complicated ones. So for our first one, you might know that speed also known as velocity, is calculated by taking the distance traveled and dividing by the amount of time it took. So here, v represents velocity, d represents distance, and t represents time. So if we travel 40 kilometers in 2 hours, then v, our speed or our velocity, is 40 kilometers, our distance, divided by our time, 2 hours, which equals 20 kilometers per 1 hour. So we have this nice formula. It's probably pretty familiar to you. If you took science last semester, you've definitely seen it. If you're taking science this semester, it may not be one that you've seen, but it's probably one that you're comfortable with from before this year. So what if I wanted a formula for time? So if we know that we traveled 200 kilometers, so we know the distance, at 40 kilometers per hour, so we also know the speed. How long did it take? We want to know the time. Well, one thing we could do is plug all of these things into the original formula and just try and solve for t from there. But suppose we wanted to answer a bunch of these questions. We had a lot of questions where we knew the distance and we knew the speed and we needed to find the time. Then we would prefer to have our equation rearranged so that we had a formula in the form t equals. So what is the formula for t equals? Well, we can work it out logically here, but we're going to use our equation solving steps instead, so that when we get more tricky ones that we can't work out logically, we'll have a model for how to do them. So we're going to rearrange the formula v equals d over t, and we're going to try to isolate t and get it all by itself. So right now, t is in the denominator. We don't want it in the denominator. We want it up on a regular spot. So we are going to undo this division by t. How do we undo a division? Well, we do a multiplication. So we're going to multiply both sides of this equation by t. And I want to pause and do a little side thing here. If we had something like this, 10 equals 5 over, 10 equals x over 5. Okay, so you can see the operations are the same. We have some number on the left side, and we have a division of two numbers on the right side. So both of these are the same setup. Here, they're all variables. So all of these numbers have unknown values. Here, two of the numbers, we know their value, and so we can write it down. One of them we don't, so we have to use a variable to represent that number. If we were in this situation, how would we solve for x? Well, very easy. We'd multiply both sides by 5, right? We have a division by 5. We want to get rid of it, so we're going to multiply both sides by 5, and then we'll end up with 50 equals x, or x equals 50. Same exact idea here, except instead of 5, a number whose value I know, I have t, which is a number whose value I don't know. But I can still multiply both sides by t. Since I use the same letter, it's going to have the same value as this t, and work from there. So then I'm going to get d times t over t. Those will cross out. T divided by itself is 1. 1 times d is just d. And over here I have vt. And then, as with all equations, I can flip them because equal sign doesn't have any direction to it. So d equals vt. Now, we're not done, though, because we actually wanted a formula for t, for time. Here we have a formula for d, distance. So how do we do that? Well, we want the t all by itself. I'm going to undo that little flip I did here. We'll just go back one. So we have vt equals d. We want t all by itself. Right now it's being multiplied by v. How do we undo that multiplication? Well, we're just going to divide by v. And whatever we do to one side, we have to do to the other. V divided by itself, that's 1. So 1 times t is just t, and we get t equals d over v. Welcome, Alan. Nathan, thank you for the update there. So Alan, just to catch you up, and I know there's a few other people who just come in, we're taking a look at formulas. So like velocity or speed equals distance divided by time. And we're taking a formula for one thing, in this case, a formula for velocity. We're rearranging it to get a formula for something else, in this case, a formula for time. So here, if we know our distance is 200 kilometers, we know our speed or our velocity is 40 kilometers per hour, we can do distance divided by speed, 200 divided by 40, the answer is 5, and so that tells us it took 5 hours. So let's do the calculation. We're going to go t equals d, which is 200 kilometers, divided by v, which is 40. Whoop, try and write that correctly. 40 kilometers per hour. And so 200 divided by 40, we get 5. And then dividing by a dividing by of hours is the same thing as just regular hours. Just like subtracting a negative is a positive, dividing and division is like a regular multiplication or just having the hours there. So this is 5 times 1 hour. Kilometers divided by kilometers cancels out, so there's no kilometers in our final answer. And we have an answer that is in units of time, which is good because we wanted a time. So now we have this formula that we've got from rearranging. It's a formula for time in terms of distance and velocity. Okay. If you have questions, type them into the chat. I was told yesterday that it seemed like there was a pretty big lag between me saying something and it getting to your computers. So I'm going to wait for a bit of time. If I start talking again before you've had a chance to type your question, please just put the question into the chat anyway. I'm going to try and keep an eye out on the chat. And even if we've moved on a little bit, if you have a question, I'd still really like to address it. So please do type it in and let me know. All right, so we'll take a 10-second pause here. Let people type in any questions and see what we get, and then we'll move to a trickier example. Okay. So again, if I've just started in and you're not quite done typing your question, please go ahead, fill it in. So we're going to take a look at a second example here, and that is our formula for area of a circle. So you probably remember A is equal to pi times the radius squared. So what if we want a formula for R? So let's say we know the area of a circle, we want to find out its radius. Well, we can go and do the exact same thing. Pi r squared, we're trying to get r by itself, so we want to get rid of that pi. Since it's multiplying the r, we're going to divide by pi, and whatever we do on one side, we have to do on the other. So that's our first step. I'm going to work sideways here because I'm almost out of paper. So pi divided by pi is 1. So we end up with a over pi equals r squared. I'm going to flip the sides here. R squared equals a over pi. And now the last thing we need to get rid of is this squared. So as always, we ask ourselves, well, what's the opposite operation? The opposite of squaring is square rooting. So we're going to square root both sides. And you can see here I square rooted the entire fraction, not just the numerator. Got to do the same thing to the whole side on both sides. So square root of a square leaves us with just r. There's a tiny little mathematical detail I'm glossing over here. You'll talk about it more in grade 10. And on the other side, we have square root of a divided by pi. Okay, so let's take an example here. If the area is 78.5 centimeters squared, the radius is, and again, a new piece of paper here, continue. So our area is 78.5 centimeters squared. We want to find out the radius. Well, we can just use our formula. R equals square root of A, well, that's the area, 78.5 centimeters squared, divided by pi, and then I can plug that into a calculator. So I'm going to go 78.5 divided by pi, and then I have to square root that. So I'm going to go second function square root, and my answer from the last calculation, and we get 4.998, or very close to 5 centimeters. So now we know if our circle has an area of 78.5 centimeters squared, that means its radius is 5 centimeters. So you can see that this technique of doing solving steps on both sides is really allowing us a lot of different things, including this nice rearrangement of the formulas. I'm going to do one more for you. This one's a pretty tricky one, definitely more complicated. So if you think back, we talked about cylinders. I think we just did the volume. We didn't do surface area. So I'm going to share with you now the surface area formula for a cylinder. It's pi r s plus pi r, oh no, sorry. This is the formula I want, but it's not for a cylinder, it's for a cone. So example 3, for area of a cone, the surface area is pi rs, that's the lateral surface, the sides of the cone, plus pi r squared, that's the base of the cone, and the base is a circle. So pi r squared is a circle area formula, makes sense. So let's say we wanted to figure out the slant height of a cone. Well, that's S here in the formula. And so we would use our solving steps to get the S by itself. So first thing I'm going to do, I'm going to subtract pi r squared from both sides. And again, we're always doing opposite operations. So I had an addition of pi r squared. So I'm subtracting pi r squared. And we're always doing the same thing to both sides. Subtract pi r squared on both sides. All right, a minus pi r squared over here. those two subtract to 0, we have just pi r s left. Well, we want just s, so we can divide by pi r on both sides. And remember, it has to be the whole side getting divided by pi r. Pi divided by pi is 1. R divided by r is 1. 1 times s is just s. And so we have a minus pi r squared over pi r equals s. Or if we flip it, s equals a minus pi r squared over pi r. And so now I have a formula where if I know the area and the radius of a cone, I can find the slant height of the cone. All right, so that's 3 pretty good examples. I'll take any questions that you have. If you don't have any questions, if you can just type a 1 in the chat to let me know that you don't have questions. And if you do have a question, you can type that into the chat and we'll follow up on it. Cool, thank you folks. I'm seeing some of those appear in the chat there. Give it a little bit longer and see what other people have to say. Okay, so we've got 8 out of 17, 10 out of 17. All right. So if you do have a question, please type it into the chat and I'll answer it, but we are going to keep moving. So now I'm just going to give you a chance to try a couple of these. So the first one here is to take the formula for the area of a triangle. So base times height divided by 2, and to rearrange it for height. So see if you can take that formula and make a formula where if you know the area and the base, you get the height of the triangle from the formula. Once you have an answer, you can type it into chat and we'll go from there. Take a moment, try it out. Looks like we're having a couple of people join as we go here. If you've missed what we've just done, we're working on rearranging the formula A equals BH over 2 to get the H all by itself. And we're going to do that with our solving steps. So how can you get rid of a divide by 2? How can you get rid of a multiplication by B? And when you have an answer, you can just type it into the chat. Thank you, Owen. Thank you, Adona. Max, I'm going to assume the 1 means that you've got a good answer. You're welcome to type your answer into chat if you'd like. Let's get a few more answers in chat before we move on. Thank you, Jackson. Thank you, Alan. Thank you, Emma. All right, so it looks like people have had some success with that one. The answer, as we're seeing from many people, is H equals 2A over B. And there's a lot of ways you could write this. You could have had A times 2 divided sine B, lots of different ways. But as long as that's the calculation, 2 and A are multiplied, and then you're dividing by B, you have a correct answer. All right, and we'll give you one more to try here. So for this one, we're going to look at perimeter of a rectangle. So perimeter equals twice the length plus twice the width. And we'd like to rearrange this one for the width. So if we have the perimeter and the length of a rectangle, how do we find the width? What's our formula? So give that a try. And once again, once you have an answer, please type it into the chat. And that way we'll know when people have had time to do it. Looks good, Jackson? Looks close, Nathan. The division by 2 part can be a little tricky, and we'll go through this one together. Okay, I'll give it some time for a couple more answers to get posted in the chat, and then we'll give it a try together. Thank you, Alan. Thank you, Jordan. All right. So if you're still working, please feel free to continue with your work. Post your answer when you get it in chat. We're going to take this one up together here on the stream. So we want to get the W by itself. So we want this 2L term to go away. And since it's positive 2L, there's an invisible plus sign in front of it. We're going to subtract 2L from both sides, and that will make it 0. So 2L minus 2L is 0. And all that's left on this side is 2W. And over here we have P minus 2L. Now we want the formula to just be for W. So we're going to divide to get rid of the 2. And over here, you can either do a big divide like that, or you can distribute the division and divide everything on this side by 2. And that's probably the choice that gives you the simplest final answer. So 2 divided by 2 is 1. 1 times W is W. P divided by 2, there's nothing we can do to simplify that. But here we have 2 divided by 2. That's 1. So it's just minus 1L or minus L. And then we can turn it around because tradition is that we put the isolated variable on the left side, and we get perimeter divided by 2 minus the length gives us the width. So example, if perimeter is 40 centimeters and length is 12 centimeters, then the width equals 40 over 2 minus 12, according to our formula. 40 over 2 is 20. 20 minus 12 is 8. So if our length is 12 centimeters and our perimeter is 40 centimeters, then our width will be 8 centimeters. Okay, that's actually it for today's lesson. The homework is posted up in the classroom. It's 6 questions from the textbook, page 368, number 5 through 10. Some of them are on the easier end. The last 2 are a little bit trickier, but I think with what we've seen today, that you should be able to get them. If you do have questions, for sure, send me an email or post a comment in the Google Classroom. I'm always really happy to help answer those. Thanks to the Waterloo Region District School Board for sponsoring this video. Don't forget to like and subscribe down below. Take care of yourselves. If you have any questions, please feel free to ask them now, even if it's about things from previous lessons. And if you're one of the last couple people, if you can just leave the chat open until everyone's done asking their questions, that would be very much appreciated. Have a great rest of your day. Take care, Nathan. Alan, the pages are listed in the classroom post. So day 13 of remote learning, it says, after viewing the lesson, please complete and hand in page 368, number 5 through 10. And anytime you want to see it, you can just find it right in that post there. Okay, folks, I think that that's it. Sounds like everyone who had questions has had a chance to type them. If you haven't had a chance to type your question, please just copy and paste it into an email and send it my way. Have a good rest of your day.